In previous lecture, we explained the testing hypothesis when we have two different groups and we are measuring a continuous variable by the independent t-test and also in the non-parametric data by the test man-whitney u-test. And now we are going to explain what if we have the same group of people or we matched and paired them. Let's say we have a group of people as before and then we have the same group after. So it's possible that we have an intervention in the middle, and also we measured a continuous dependent variable here, again blood sugar as an example, and we want to see what happens, the significant difference here before and after or not. In this case, so the null hypothesis will be there is no significant difference for blood sugar after intervention A. We want to reject it or we want to accept it, and we need a p-value to be able to do it. And in this case, for testing this hypothesis, we are using the paired t-test, and this is for parametric data. In case that we have non-parametric data, we are using the test called Wilcoxon matched pair test or Wilcoxon signed rank test. So let's see what kind of assumption we have here. The assumption number one, the existence of the continuous variable, check. The assumption number two, the existence of the categorical dichotomous variable, also check. That we have here group 1 and group 2. One more thing that's here is important is matched pair that we use here in case control studies. We may have the second time or the second group as matched one by one with the group of case, and then they are control, so we can use in this case a paired test also. There should be no significant outliers. This one should be checked as we did also in independent t-test, and the distribution of the difference in the dependent variable. Pay attention here. Difference in dependent variable. It means, for example, the changes that happening in blood sugar. So the first measurement, the second measurement, we say minus first minus second or second minus first, doesn't matter. And then we have to check if it's approximately normally distributed. This is assumption number 5 that we need to calculate. Let's back to our example that we have data set from the survival manual. It's the SPSS. This is the book, and they have the online, and you can have these statistics SAV. We can find those here. So we have the question is, does the participation at the course has an impact on the participants of for fear of statistics? So in this case, we decide to see if, for example, fear of a statistic day 1 and fear of a statistic day 2, there is a significant change happen for all the participants of the same group, and the continuous variable as a scale for fear of statistics. But first, the 5th assumption, and here we can go to the transform and compute variable. And here in the computing variable, you're making a new variable, like as I explained here. Let's zoom a little bit. So we have I put the name difference, should be supposed to be 2 and 1, 2 to 1. So we are measuring fear of a statistic day 2 minus fear of a statistic day 1. And then you just click on the OK, and you will have a new variable, which the name is here. You can also put the type and label by clicking on this tab. Then what we have as the results here, let's like here, yes. And then we are going to, as I said, we are going to have a new variable. Then we should explore it for distribution. So you will go to Analyze and Descriptive Statistic and use the function explore, and then you are going to explore for the new variable, which is different between day 2 and day 1, and also the you need also to click on the plots and then choose the normality plots with test, as we did have it also in the independent theta. So if you want more detail here at how to read it, please look at the video that we have for the independent thetas, and we explain this part. And here, for example, for smaller groups, a smaller sample, we use the Shapiro-Wilk test to see if it's not significant. Then we say, okay, the distribution or the normality is not violated, so we can use the test if it's not significant. And also if it's bigger, we can use the QQ plot to find it's normally distributed approximately. So this is the assumption number 5. Of course, you can check the plots for the outliers and make the decision. As I said, you can see these parts for the checking the outliers, and explanation of Shapiro-Wilk. You can find it in the independent t-test video. So here we go and now do the major part that we want to check. There is a significant difference or the impact is significant. So we are going to analyze comparing the means as we do, and here you choose in paired sample t-test. As you see, we have one sample t-test, independent sample t-test, and here is paired sample t-test because it's paired group. And then you are going to put your variables in the 1 and the second here, and this is it, and you just can click on OK and you will have the results. And there is only one line there. The previous one you had the 11th test, for example, but here we have only one, and then you are looking at the paired sample t-test, the significant two-tailed, and if it's less than, for example, 0.05, then you are calling it a significant difference, and you can say yes, it was an impact of the statistic on the level of fear of the statistic. But does this impact increased or decreased? Then you need to look at the mean. As you see here, that day 1 we have 40 and day 2 we have 37. So the decrease is significant. There is a decrease in the fear of the statistic after the first day, and it's significant. This is how we report this one. There is a significant decrease in fear of statistics in the second day. Just allow me to go directly to the part that we can do non-parametric. And here, as you had also before, we go to analyze, this time as non-parametric test. If one of the assumptions is violated, then we use this test. And here you go again to legacy dialogues and then 2 paired samples. Simple. Because if you know what you are doing, then it will directly tell you where you should go. And also here the same, we put the variables as 1 and 2. Remember that look and check is Wilcoxon. You have it already there, and you click on the OK, and the result will appear like this. Again, you have a significant value also if you go non-parametric, and they have also a very good data here that as A, B, C is explained. For example, you have 25A, as you see, you have it here. So you read this one. So you say 25 people, fear of a statistic day 2 is less than fear of a statistic day 1. You read this line as A. And for the B, 4, here is the B, for the 4 people, 25, this is the number, and here number is 4 for the B. Fear of a statistic in day 2 is more than fear of statistics in day 1. So they have more, but as you see, we have more in the A, and then you can also have C that there is no change. It's exactly the same. But the final result is important, and this has become only as descriptive that you can use and write your results.